right. Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. A big Happy New Year to all the classrooms out there. This is our first week of live events since classrooms have been back in action since Christmas break. So we're really excited to have everybody tuning in and back along with us. If you do want to head to the website, exploringbytheseat.com, you can find all the live action we have coming up. Register for the events in January, and we'll be announcing a ton of February live events soon as well. So exploringbytheseat.com is where you can find all of that action. All right. Well, we are going out into the field. This is one of our favorite things to do when we can go live in the field and bring really cool content to classrooms. And we're going to do it with our friends at the Around the Americas expedition. So before the break, we've been following along with them. We left off. They were still in that Atlantic Ocean area around Puerto Rico, and we have a lot of progress to catch up with them. So if you don't know, this is a 15-month voyage starting May 2025. It'll circumnavigate North and South America aboard the 48-foot sailboat One Ocean. It's focused on scientific research, education, and community outreach to raise awareness about ocean health. It builds on an original journey back in 2009 and 2010. So this expedition is going to collect more data and connect to that initial baseline data and see how our ocean has been changing. So let's find out where the team is right now. Let's bring them in. There we go. Hey guys, how are you doing?
Well, hi, Joe. Hi, everybody. Thank you for joining us. I'm Jennifer, and we have Taz and Captain Mark here. And thank you very much. And we also have crew member Mike. He's back at work at the Marine Tech Center where this beautiful One Ocean boat was built. And thank you for having us.
Right now, we're in Isla Lobos de la Afuera, and it's right off the coast of Peru. It's a marine protected area, which is vital to the sustainability of our oceans. So we decided to come here just yesterday, and it's been absolutely incredible so far.
Oh, it has. We had Christmas in Panama. We went through the Panama Canal just before Christmas, came and stayed in Panama at Christmas. And now we're about 7 degrees south of the equator. So now we're about 1,000 miles south of Panama. And there's a little island group there. It's an amazing thing. And one of the things we've noticed along the way, and you've heard us talk about it, are sea surface temperatures. You may remember back in the Arctic, when we started through the Arctic Passage, the seawater temperature was warmer than expected, 58 degrees. As we came down through the Atlantic, that went up to the 80s, 70s and 80s. So it's been very, very warm water. We had some 90-degree sea surface temperature water, ocean water, a few days ago. But now, just on the outside of these islands, the Humboldt Current brings nutrient-rich water and cooler water up from the end of South America. The water now temperature is about 71 degrees. So we're seeing a lot of sea life that we haven't seen for a while. Just an abundance. Beautiful stuff.
Incredible sea life. I mean, I'm so excited about what I'm seeing because all my life I've wanted to see a penguin. And guess what? Today I got to see a penguin.
Penguins right over there. Which we can show you.
Joe actually has a little video. We could play the video real quick here of just a few things we saw this morning. We went out for a little dinghy ride before we take off. We'll probably bring up anchor after the classroom and head back out and head south. But Joe, are you able to play that little video?
All right, here it comes.
Here it comes. So that's where the little circle on the left by Peru there, that's where we are. And that's what the islands look like. It's just filled with guano. And we saw penguins.
There we are.
And then we have all kinds of different birds. It's a marine wildlife. Oh, I don't know why it's not going quicker than that. Stuck on penguins.
It's okay. It's a good thing to be stuck on.
Yeah, these are the Humboldt penguins.
Yeah.
I don't know, Joe. Are we able to go to the slideshow then if that doesn't work?
I think it's a video, so it'll probably just
Did we freeze?
No, the time is
Hello.
still
Okay, well, so anyway, we are going to be here for a while. We've seen all kinds of wildlife. I don't know if you can hear us or not. Someone could let us know.
And one of the reasons
I can still hear you.
That this
okay, thanks, Mike.
That there's abundant wildlife here is that the ocean depth right out in front of this little island is about 300 feet. In 20 miles, it's 19,000 feet. So it's the deepest trench, second deepest trench in the world. And that brings all this cooler water and nutrient-rich water north in the Humboldt Current. So it's an amazing place. That's why there's a lot of wildlife attracted to it right now.
Some other kinds of birds that we have got to see today. Tess, you want to tell them some names of those ones you?
Yeah, so we've seen the Incan tern, which is really cool looking. It almost looks like it has a little white mustache. And hopefully those pictures will pop up here pretty soon. But we've seen those, Peruvian pelicans, blue-footed boobies, which are unique to this area here, other types of boobies as well, sea lions. We've also seen little tuna crabs in the water, just filling up the entire ocean right here. And yeah, we just saw some dolphins as well. So lots of marine life here, that's for sure.
Joe or Mike, are you still there?
Yeah, I'm still here. We just have a generic screen, but I can hear you and it's still rolling, I believe.
All right. Okay, good.
That's too bad.
I'll try and email Joe and see what's going on. I'm not sure if everybody's seeing the same thing as we are, just a generic screen, but we'll tell you a little about what the rest of our journey is going to look like.
Yeah, let's try to show them in person.
Can you see through our camera? I think they can only see the generic screen.
No,
right?
just an exploring by the seat of your pants screen is up right now.
I don't know what happened to Joe.
Definitely, it must be a technical thing. So we can still hear you, though. At least I can.
Okay, well, why don't we tell you, Mike, where we're planning to go?
Well, so
there we
next
go.
stop.
Joe's back on the camera.
Hi, Joe.
Sorry, team. Everything crashed on my end, so I don't even know if the video played.
It did not play.
Judging
but
by the comments, and they're saying they didn't see it, we're going to have to try that again.
I'm hoping they heard us. We were chatting a bit.
Okay.
Try it again.
Let's try it again.
Okay.
I've switched my connection. I'm using the cell connectivity now. Whatever's going on here, maybe it's the snow. It's not cooperating. So we will give this a try, and we'll try that again. There we go.
Okay, so there we are. That's the islands, and that's the island that we are right as we
It's
speak.
white. It's white. It's not snow. It's guano from those little penguins and all the other birds. Humboldt penguins.
And then we've got some booby, and that's her baby there. And what kind of birds are those, Tess?
Those are the Incan terns that I was talking about before.
And those are some blue-footed boobies.
And they really are blue-footed.
And that's another booby there, just nice up close for you all to see. And more penguins with their young. Those are young babies. And a mama and her baby. I was just so excited, everybody, because I've never seen a penguin, except for in a zoo. So I was just beyond excited. The penguin got scared, the baby, and she went running back to its cave. And then you'll see it sitting in its cave there, hiding
in the shadows. Hiding in the shadows.
So it's been quite a morning, just beautiful morning, being able to see all of this and sharing. And there's fishermen here. They go out of the nature reserve to go off and fish, but they hide out because we're way out in the middle of the ocean. But quite a wonderful deal. But thank you very much, Joe. That's where we're at. And then we unhook our anchor and we head out, start heading south. And our next stop hopefully will be Chile.
Valparaiso is about 1,700 miles south of here. So that's an 11, 12-day run, and we'll be off.
Okay, very cool. Well, we're going to keep our fingers crossed that during today's event, something cool pops up. A dolphin, a sea lion, some crabs.
Yeah.
Who knows? So we're going to keep our eyes out for that. So if you see the camera suddenly go and everything change, I'm going to keep my eye out for that. But I know we also have a guest speaker who's going to hang out with us today.
Yes. Why don't we bring in Janice? And she's coming in from Puerto Rico. And we met Janice when we sailed there. And we have a wonderful connection with her. She works for Applied Physics Lab at the University of Washington with Andy Jessup, who's one of our main scientists doing the heat flux research for us. And we met Janice in Puerto Rico, and we had a really wonderful talk. And we did a little podcast with her. And she's here to present today. Hi, Janice.
Hi.
Yeah.
How are you?
thank you so much for joining us.
Good to see you
Yeah,
again.
thank you for the invite. Very excited. Very cute, the penguins.
Yeah, they're cute and protective of their young.
Yeah.
All right. Well, Denise, we're going to let you take over for a little bit. And then we're going to do some Q&A action. But I'm also going to tuck everybody else backstage. But I'm going to watch very closely backstage to see if the camera suddenly goes to the water. So I'm going to keep an eye out for that, because who knows what could happen. But Denise, if you want to take over for a bit, the stage is yours.
Yeah, thank you so much. Okay, let me know if you guys can see the slides.
Hopefully you'll have better tech luck with me. I can't believe everything just turned off in the middle of the event. I'm glad I was able to get back in. All right, I see your screen loading. Good start. If you want to try and go full screen, that looks perfect. All right, Denise.
All right, thank you so much for the invite, everybody. My name is Perez Valentin, and today I'm actually talking to you from Puerto Rico, but I will be talking about the Arctic. So yeah, let's just get started. I'm going to be talking about sea ice advance in the Western Arctic. And first of all, I want to talk about, the differences between the two types of ice that we have. So we have sea ice and we have land ice. And land ice is what we know as glaciers. So that's any ice that is attached to a landmass. So for example, in the Arctic, we have the land that is ice cover on Greenland. And in the Antarctic, we have land ice that is over the entire continent. So these massive quantities of ice over land is what we call ice sheets. And their loss in volume actually contributes to increases in the sea level rise. Contrary to sea ice, which is the ice that we see that is floating in the ocean, it can look like this, which we call it pancake ice, or it can look like really big icebergs. But however, these do not contribute to a rise in volume when melting. But it is still has other implications that we will talk about in the duration of this talk. So sea ice undergoes seasonal changes. So in the Arctic, sea ice melts in the summer, starting late April, early May, and then it dips down to its lowest point around September. And this time period is varying as sea ice keeps getting thinner and thinner, affecting the entire Arctic ecosystem, as you can imagine. Over here on the left, I have sea ice extent decreasing over the summer. This past summer, this is 2025. You're going to see a yellow contour line right now, and this indicates the average minimum over 29 years, so from 1981 to 2010. And here we can see that most of the places are, the extent of the ice is very, very minimum compared to that average line. And the difference is quite remarkable over the Western Arctic. As you can see, I don't know if you see my little marker, laser pointer, but over here, that changes is quite remarkable. So, if we look at the summer sea ice extent over the years in the Arctic, we can clearly see a decaying trend. Here, this is a little movie showing the average sea ice minimum area over the years. And you can see this clear decaying trend, and then a really, really big jump in 2007, and then a massive another minimum on 2012. Actually, this 2012 year, the Arctic reached a record low minimum and extended about 3.41 million square kilometers, which is about the size of India or Argentina. So as I mentioned before, this Western Arctic region, the sea ice is becoming thinner and thinner, and it's becoming way more mobile. So this area in particular in the Western Arctic is very, very susceptible to drastic changes in sea ice coverage. And this is the area that I wanted to focus my study on. So what are some of the reasons why we care about changes in the Arctic, or changes in sea ice in the Arctic? As most people would first thought would be, the endangered species like polar bears. And these little bears rely on sea ice for mobility, so to capture any prey and to conserve energy. So therefore, tracking the sea ice is needed for their tool and their nutrition and the ability to reproduce. Scientists actually predict that these species would be in extinction in 2100, so in 2100. But I think even more critical than polar bears, even though they're really cute, is that sea ice actually acts like a mirror. It reflects the sunshine off of the ocean. Because the ocean is very dark, it absorbs a lot of shortwave radiation from the sun, and that sheet of ice actually protects us from that. So sea ice is very important for keeping the Earth cool. Another really important aspect of sea ice is that it acts like a barrier against strong atmospheric winds. So any type of typhoons or strong wind conditions, sea ice acts like a damping or a barrier against this strong conditions. So this is particularly important for coastal communities around the Arctic. This was a picture in one of the coastal communities, and they really rely on sea ice to protect them from these storms. Another really big key to sea ice is that it acts like a blanket. So it keeps heat trapped in the ocean. This has been observed in the Western Arctic, particularly in the Beaufort Sea, but all over the Arctic, really. Salinity is very important because in the Arctic, the ocean is salinity stratified. So that means that you have pockets of warm ocean water trapped below really cool and fresh water. So overall, to adapt to these changes in sea ice, we must understand it. So understand the physics of it. We must monitor it, and we must predict it. And this is just a scientific opinion, but we're doing okay-ish in understanding it. We're doing a little bit better in monitoring it, but we're pretty bad at predicting it. So it takes the first two to do it really well to be able to predict it okay-ish. So starting with how do we actually monitoring it? And as you probably know, one of the big keys to monitor sea ice is using satellites. So satellites use altimetry, which is a pulse that is emitted at the surface of the Earth and then bounce back. And typically we use two types of satellites for this. So we use the NASA ISAT-2 and the ESA CIROSAT 2. One is a laser and another one is a radar. So the laser has a narrower band so it can detect the snow depth. And then the radar detects the sea ice elevation from the surface. So with the combination of both, we know what is the freeboard height with respect to the sea surface height. And then we assume hydrostatic equation, and using the Archimedes principle, we do an estimate of the sea ice thickness. Another way to measure sea ice or the overall conditions in the Arctic is using doing field work, so with instruments. These are some pictures from September 2022 as part of NASA's SASE program. So SASE wants to understand how sea ice advances in the autumn. And by looking at the sea surface conditions and the ice conditions during the growth period. So some examples of these instruments are here on the left. We have an under ice float, which has a sonar at the top, and then it sits under the ice and it looks up and it sees the evolution, or the freezing of the ice. On the bottom here, we have what we call a jet SSB, which is like a little jet ski, and then it runs autonomously, and it has a keel looking at salinity, temperature at that very surface of the ocean to track, the fresh water and the temperature and how it is distributed across the sea ice edge. Here on the bottom right, we have an ice mass buoy. So drill a hole into the ice, and we put massive buoy in the ice, and then it tracks the changes on volume. And here I am on the Woolsat. The Woolsat actually had an S-band radar, so we can see the different types of ice conditions. And actually, with this data, we were able to produce a product based on different levels of ice. So working on the SASE project, we actually departed from Nome and went all the way up to 150th west, up to almost 70 at some point degrees north, tracking, these changes in sea ice, and how is the upper ocean surface changes with these sea ice conditions. And then this is, if someone was wondering how are the conditions while we were there on transit, this is kind of how it looks like. It varied really much depending on the amount of ice that we would see. So when we were actually inside the ice or more in icier conditions, the sea state was pretty not as rough as we were in open ocean. So this is kind of open ocean conditions. Okay, so what SASE was trying to understand as an overall question was what happens, from melt to freeze up? How does sea ice really advances in the fall? And to understand this, we need to really look at all of the different processes that happen during this time, right? So ice, when it's melting, it leaves an open ocean area. And then you have things like atmospheric forcing from winds. You have things like your solar radiation coming in. And then you have interchanges with the atmosphere. So you have your turbulent fluxes and surface heating. You have that thinner ice that is on the marginal zone, advecting, moving around from the wind as well. And then you have that fresh water that is setting up the stratification in the ocean, where you have fresh and cooler water, and then more salty and warm water at the bottom. So in order to kind of understand in a more global aspect what's happening to the ice as it's forming, I went ahead and run a physics model, and we put all of the things that are dynamics into one term, and then all of the things that are the thermodynamics in another term. So ice moving, for example, that's dynamic, and the changes in heat from the atmosphere and the ocean, that's thermodynamics. So all of the different processes, you can just separate them into two aspects and make the question, okay, how is sea ice forming? Is it by dynamics? Is sea ice actually moving into the region from the atmosphere, or is it just growing because the ice is cold? And that's kind of what I did or been doing over the past few years. And yeah, the big question is, how is sea ice advancing in the Western Arctic? And one thing that we found is that when we look at the advection and versus the production, and we look at different regions in the Western Arctic. So over here, I kind of separated the Beaufort into two regions, the Eastern Beaufort and the Western Beaufort, and then you have your Chukchi Sea. When you look at those three regions separately, you can clearly see that are very distinct in how sea ice is forming in the fall. So advectively, so that ice kind of moving in the region, we see that in the Chukchi and in the West Beaufort, you have a positive net influx of ice from advection. So the ice is moving in, versus in the East Beaufort, the ice is actually leaving the area. So you have more ice moving out of that area. In terms of production, so production is, think of the thermodynamic component. Ice is basically growing. So that means that it's just cold and ice is growing vertically. And we see that for all of the three regions. However, we do see that the Eastern Beaufort is significantly higher than both the West Beaufort and the Chukchi Sea. This is kind of another way to see it. As you can see here, this is the advection on the x-axis and then production or thermodynamics on the y-axis. So when you divide all of these three regions and then you plot it for every day of the year or day of advance. So here is, I would say, like late melt, early freezing, and then as it gets a brighter blue, it's kind of freeze up. So there's already ice in the region. So in the West Beaufort, you have a lot of advection, compared to the Chukchi. The Chukchi and the West Beaufort at the beginning of advection are quite similar, but then in the Chukchi, it kind of the advection decreases and ice is just forming because it's cold. So it's the thermodynamics kind of kicks in there. In the East Beaufort is actually just thermodynamics. There's little to no advection. It's actually negatively advective. So ice is still coming out of the region, but all of the ice that was produced is produced just solely out of thermodynamics. Another question that we have then is, so why is this happening? Why do you have this conflicting pattern, specifically in the Beaufort, from ice being advected and then ice being negatively advection and then a positively advection. So ice being divergence, and then you have convergence in the other side. So we look at the last scale conditions in this region. And one really key feature here is what we call the Beaufort gyre. And the Beaufort gyre comes from a large atmospheric circulation pattern called the Beaufort high, and it's quasi-stationary. You do have, however, some years where that reverses and it becomes a Beaufort low. So there's a shift on the gyre, and this is observed here. So here you have your zonal wind component, and then these are your typical conditions as to a Beaufort gyre, but you do have a Beaufort low happening in 2012, and I chose to look at the differences between these 2 years from the sea ice advance. And what we see here is that in 2007, when you have a Beaufort high, you have your typical conditions in these three regions where you have ice going out of the Eastern Beaufort, but coming into the Chukchi and the West Beaufort. You actually have a much higher amount of sea ice coming into the West Beaufort than the Chukchi, which is not something that we saw when we do the entire climatology. Versus when you look at the 2012, you actually have positive advection. So a sea ice converging into the Eastern Beaufort, which is not something that we see typically. So so the different atmospheric conditions really shape the sea ice distribution in this area. And it's really because this area has such thin ice right now that is very susceptible to these different atmospheric changes. So some takeaways and future implications in a warming Arctic. So to summarize, in the Western Arctic, it exhibits kind of three different patterns or three regimes. One that is thermodynamically enhanced, which would be the Eastern Beaufort region. Another one, which is dynamically enhanced, which is the Western Beaufort. And the Chukchi is kind of a combination of thermodynamics and dynamics. We can also see how changes in the large-scale atmospheric circulation patterns, like the Beaufort High, affect the spatial distribution of sea ice formation. And then, so with this, what can we expect in the Western Arctic or the Arctic in general? As ice is getting thinner and thinner throughout the whole Arctic, we can expect faster thermodynamic advance due to more efficient heat conduction through thin ice. However, since the ice is thinner, it is more susceptible to fracturing and drifting under wind and current stresses. So this increases the sea ice mobility, which will allow for more frequent divergence and convergence. So you have kind of a conflicting things happening between the thermodynamics and the dynamics. As you have thinner ice and your ice keeps melting, because of that salinity stratification, you can have more ice expansion. However, it is very important that, if in the future we get a year that we can say that it has a bigger area coverage than previous years, do remember that the ice is thin. That is what is critical here. Ice is thinning. And just because we see a bigger area, that doesn't mean that the year after is going to be, it's going to be covering more. It's just kind of a ticking bomb at this point. But yeah, this is my presentation, and I guess I will take any questions.
All right, let's bring everybody back in here with us. There's our see, they're out enjoying the sunny weather. And here I am in Canada with snow. That doesn't seem fair. Oh, I think you're still on mute, Jennifer. We can't hear you. Well, Janice, thank you for that. Janice, thank you for that great presentation. Lots of information there that you're using to cover and monitor these really important events. And we do have some questions, so we're going to get to those questions shortly as we look at the islands there.
Can you see the sea line out here, guys?
Oh, let me try and go big.
Oh, just kind of dove down, but I thought I would give it a shot and bring you. Oh, there you go.
Oh yeah, I just saw him pop up, him or her. Yeah, cool. Let's see if they'll give us another appearance.
Let's see. I will definitely tell you if they come up again here. And we're looking for tuna crabs. We've got a lot of them, and we'll try and show you those up and close and personal as well.
Oh yeah, we saw a bunch of them just before we went live. So fingers crossed they come and swim past again. That'll be cool. Okay, well, if you are tuning in via YouTube, don't be shy. We already have questions sent in, but keep the questions coming because we do have some time for some good Q&A action. So I think the first one we'll start off with, this is from a group here in Canada, and they're wondering what you did. So this is for our Around the Americas crew. What did you do on the ship? How did you celebrate Christmas?
Well, actually, we had most everybody went different places. So we were planning to head over to the East Coast and head to South America to Uruguay, but weather conditions didn't permit that. So Tessa's family was headed there anyway. So Tess flew to Uruguay. right?
Yes.
Amazing time there.
Incredible.
Mike went home for Christmas. John Eldon's on board, and he went to Australia to visit his family. And then Mark and I ended up staying on board because we had some electronic issues with the boat. So we were over in Panama, and in Panama City, where it was stinking hot, but we stayed there for Christmas. Here's
All
Mark.
right.
We celebrated with locals on Christmas Day. It was
We did.
It was fun. They had a parade. They had fireworks.
Christmas Eve is huge,
Yeah,
huge
it
there.
was-
So it was really fun.
All right, very cool. So let's get into some Q&A here. We've got a group joining us in Hamilton, and they're wondering, so Janice, this might be a little bit outside of what you're studying, but they're really curious about how the changing sea ice can impact the ecosystem, impact the life in the Arctic.
Aside from, the coastal communities in general, or kind of like more animal, like the animal?
I think they're curious about the animal side of things. Yeah.
Yeah. So when I mentioned, people are very, or the first thing that they think about is, the polar bears. But that's just one example. I'm not a marine biologist, but I can tell you that, the polar bears really rely on sea ice for mobility. So they needed to move around to catch prey, and just to rest in general. They can't really swim for that long. So if sea ice just keeps getting thinner and thinner, it's not going to sustain the bears' weight. So they're going to be starving, and eventually, the population is going down dramatically. Scientists say that they're going to be extinct in 2100. So,
yeah,
sadly the case. Yeah.
And Janice, correct me if I'm wrong, but I think sea ice plays an important role with the plankton as well, which is the base of the food chain out there in the Arctic. So changes in the sea ice could really have an impact, kind of, that moves all the way through the ecosystem.
It really changes the variability of the plankton, and exactly as you mentioned, since it's the beginning of the food chain, how that's going to impact the entire ecosystem. It's going to be really drastic. Again, I'm not a marine biologist, but that's kind of the only thing that I can tell you right now. And definitely the salinity plays a really important factor in setting up the conditions for plankton blooms. So how the variability really plays out throughout the Arctic is going to determine a lot on how these species go around for food.
Yeah. I've got a question from someone joining us in Nicaragua, and they're, you talked about sea ice and how it melts and impacts the ocean. They want to know, what about a glacier? When a glacier is melting and feeding into the ocean, what impact does that have?
Yeah. So you mean,
like, how does it differ between like sea ice melting as opposed to, yeah.
Well, I'm guessing that it has a much larger volume, so it's going to take some more time to melt. But it's depending if it really disturbs, like, for example, a heat source at the bottom that can bring it, starts to melt this really big chunk of ice. So that's going to have a larger freshwater input into the ocean. So it might even set up favorable conditions for new ice formation as the atmosphere starts to cool down. But yeah, so you do have some positive feedback, but then you're also melting that ice that it might come from land, right? So that can also disrupt the sea level rise as well. So yeah.
There's a really cool experiment you can do in your classroom to demonstrate that. Taking two trays, having one with the ice floating in it and one with the ice on something so it runs into the water, and see what difference you get if there's a change in water level between the two experiments. So that's kind of a cool one to see the difference and the impact that ice has melting from land into the water as opposed to the sea ice where it's already on the water and accounted for. So that's a cool experiment.
Yeah.
And I think one of the things we've listened to scientists talk about is that warm water, when water heats up from cold to warm, it expands. So that's a big factor in sea level rise. You're recording the temperatures that we were recording. That's big. It's a big difference between 32 and 34 degrees Fahrenheit and 80. So and the coastal communities in the north were noting that everywhere we went. Sea level rise was really what they were fighting.
Yeah. My next question here is from our crew in Hamilton, and they're wondering, you presented a lot of data. So where does that data go? Who uses it? Who do you share it with? Who can look at that data?
Yeah, excellent question. I should have put a last slide onto where that data is, but it is on PODAC. NASA, if you just Google NASA SASE PODAC, all of the data collected from that field campaign is there. It's already curated. We cleaned it really well, so it's publicly available. Yeah.
Okay, I think I found it here, so I'm going to put that link up here so classrooms can check it out. I'll put it in a banner, and you should see that come up now. I think that's it. Cool. So check that out if you want to see some of that data. That's pretty cool. It is important for it to be available, open source like that, so it can be used by all kinds of scientists, and the general public can see those things as well. So I've got another question here from someone tuning in, and they want to know about dolphins. Have you guys seen any dolphins recently?
Oh my gosh. We have seen so many dolphins literally every day. I have a sea lion coming right up here, you guys. I don't know if you can see. Oh, it just dove. Hold on, it might come back. But we have seen so many dolphins, all kinds of dolphins, especially with the Humboldt current that we've been following along from morning to night, and they come by the thousands, and they'll come off the bow of the boat, but the whole horizon will fill up with these beautiful dolphins. Even at nighttime, I've seen them under the water with phosphorescence lighting them up. Just an incredible experience. And then here at this beautiful nature reserve, right before the classroom started, a big, huge pod of dolphins just came in a big flurry, obviously chasing fish, and the whole horizon just bubbled and bubbled and bubbled, and it was just thousands of dolphins.
Right, all the way across you can't see the opening here, but all the way across the opening, it looked like a little bit of a tidal wave happening, but it was all feeding.
Very incredible, lots of fun.
You see, and that they just had their timing off. They came early. They knew when they're supposed to come. They just didn't come in live. Well, you can't win them all. That's live broadcasting for you.
It is live broadcasting. But if you check our social media sites, we've been posting a lot with the dolphins, and so you can look at our website, right, Tess?
Yeah, oneislandoneocean.com, and then also on social media is One Island One Ocean. You can check it all out, and then as we continue on, you can also follow our progress, which is really fun.
Yeah. So, Mike, we've got you on land. Firm, terra firma. When do you get to catch up next?
Yeah, so it's been different after several hundred days on the expedition to be back, but I am back in the classroom teaching again with electrical and still supporting the team. It's fun to connect with them. They have little electrical glitches here or there, or things with the boat that used to be kind of my duties. Yeah. But they've been trained up and they're doing fantastic. Obviously, they're traveling thousands of miles. And what do we look?
There was a sea lion.
Sorry, Mike. There was a sea lion. Sorry, Mike.
That's all right. But I miss the crew. I miss being on board. I miss the day-to-day of what they're doing. And, they're still doing seawater temperature and watching and seeing how everything is changing. And still connecting and doing a wonderful job. So I will continue to support them until my next break when I can catch up with the ship again.
All right. Perfect. And, that brings me to Grace, who's not joining us today. When are you guys going to hit kelp next? When can she get in on the action?
She will be joining us down in Chile. We have several kelp sites down there. So she'll be joining us on board, doing some research, and we're pretty excited to do that again. I don't know if we let you know, but the data that we received that we've been doing all the way up through North America and up to Alaska with our kelp study. They reviewed it at the University of Victoria to some degree, not extensively, but they reviewed it. It all looks like really good data. They're very excited about the research. It's the first ever done from pole to pole. And so Grace will probably continue on to do her master's with this data. So it's very exciting.
Cool.
Yeah,
very cool.
Really, really neat.
So Janice, I've got another fun question here for you. You mentioned that some things are being done well, some things need improvement. So, in a perfect world, what would you want or need to monitor the ice better?
Oof. Excellent question. In a perfect world, satellites would be able to measure sea ice volume. That's in a perfect world. We would not have to assume hydrostatic. We would not have to, estimate. It would be just purely retrieved from the satellites. That would be number one. I guess number two would be having, oh, that's so cute.
We had a sea lion saying hi to all the kids. Sorry, Janice, go ahead.
Oh yeah, no worries. Number two, I think it would be, that's hard.
I would say funding.
Unlimited computer resources to run really fine scale modeling so we can resolve really local physics and better understand them. I guess that would be my number two. And number three, I don't want to say more observations, but that's just me as a field scientist. I just want to say more observations, but I want to be mindful of the coastal communities, that they just have to deal with all of the stuff that we put in our oceans that we sadly don't recover. So for me, it would be observations that would not sit permanently in the ocean.
Yeah.
All right. I like yours, Jennifer. Funding is a good one too.
Yes,
of course.
Funding's very important for science, everybody. One thing I do keep hearing over and over again, if we could get more funding for scientists and more awareness and observations, like you're saying, Janice, that's terrific.
Awesome. Well, I've got one. I think we can squeeze one more in here before we let everybody carry on with their day. I know you guys, if I were there, I'd be in the water already. I don't know how you're sitting on the boat. I don't know and I'd be in the water. But
it'll happen shortly.
Excellent. So one more question here, wondering about how you're getting your supplies and restocking the ship and making sure you've got the gear that you need.
Oh boy, that's hasn't been a particularly fun one, but a necessary one. We make amazing runs to large grocery stores and outlets
in all the different countries we stop in.
From Panama and from the north. So we have a menu. We try to keep to so we can tell what supplies we have on board and what we're using. So that's just what we have to do. There's a lot of that kind of housekeeping that goes on. I got to say we've been eating well. And mealtime is a time to share, like it is anywhere else, how the day's been, and it's a gathering point for us.
Yeah, because we're all on different, schedule and watches. So some of us are up through the night and rotating, but we all try to meet for dinner every day, and we all take turns cooking dinner. So yeah, but stocking the boat is a big one, especially for this journey because we're out here for almost a month. So it was a lot.
Awesome.
Can we also say, you guys, you've had favorable sailing conditions, so you're using less fuel, right? You're able to get some miles in?
Oh, we've been doing a lot of sailing. It's been terrific. Yeah.
Excellent.
It's been a great week.
All right.
And what helped the grocery store is we got a fish yesterday. We got a tuna. Caught it, ate it. It was gone.
It's delicious.
Very, very cool. Well, I want to give a shout out to what we're up to next. So we're connecting again on January 21st at 12 p.m. Eastern. And this time we're going to talk about the Antarctic circumpolar current off Cape Horn, which is pretty cool. That that'll be an adventure when you guys get down there and it's time to round the horn. That'll be another big accomplishment on the journey.
Yeah, absolutely. Very excited about it. We hope everything goes well. We get down there, but we'll have Dr. Jim Thompson again, talking about the current, and really excited about that one as well. And Janice, thank you very much. It was just an absolute pleasure to hear from you and hear your work you're doing. And, in my eyes, you scientists are my heroes. Thank you for everything you're doing for our oceans. I really appreciate it.
Thank you. We'll echo that. And Joe, we can make an extra berth available at Cape Horn. So you can
let me know. I'm down.
All right.
All right. Well, it sounds like you've got a taker, so I'll have to wait for the next one. All right, gang. Well, it's great to connect. Thank you so much for another awesome connection. I don't want to leave out a shout out to the groups who are joining us today. Thank you for sending in all those great questions. I recognize some groups as well, so thanks for following along on this journey with us. And we hope to see you all later in January. Janice, it was great to meet you as well. Thanks for hanging with us.
Yeah, thank you so much for the invite. It was great. Thank you.
All right. Thanks, everyone. We're going to sign off for today. Enjoy the rest of your week. See you later.
Thank you. Thank you, everyone, for signing in. We appreciate it.